Good day everyone, you're welcome back to the channel Learn Maths. Today we're going to be looking at the topic inverse of a matrix, right? Inverse of a matrix. So pay attention, get your paper, pen, book, whatever you're going to use to take some things down for better understanding. And then let's get straight to the point. Alright, so the inverse of a matrix, let's say A, we're going to consider the matrix A, right? And A is going to be giving us, let's say, the elements 3, 2, 3, 5, 4, 1, 6, 1, 4, and 0. This is going to be the matrix, the case matrix for this video, right? And now, how do we represent the inverse of this matrix? The inverse of this matrix is represented as A with a negative power, right? This is the matrix inverse. That's the inverse. Now, before we look further into inverse, we have to be familiar with terms like determinant of A, right? This is the determinant of A. Okay, that's the determinant. Then we should also know what an adjoint is. The adjoint of the matrix A is, right? We need to find out what an adjoint is. So just get familiar with what an adjoint actually is. Now you see, adjoint is actually the cofactor transpose. Cofactor transpose. Alright, so if you're finding the adjoint of a matrix, all you have to do is find the cofactor, then transpose it, you get the adjoint, right? Okay, that will be all. Okay, I think we need to be familiar with an identity matrix, I, right? Identity matrix. Okay, just get familiar with these terms and you'll be fine. Alright, so how do we get the inverse of a matrix? The inverse of a matrix is gotten by just dividing the adjoint, or let's say the cofactor transpose, by the determinant of A. That's how you get the inverse of a matrix. You divide the cofactor transpose of that matrix with the determinant of A. Okay, I can just write this as dividing the adjoint of the matrix by its determinant, right? Remember, adjoint is the same thing as cofactor transpose, so either ways. All right, so let's find the inverse of this matrix A. Like, let's calculate the inverse of this matrix A. Now, as you can see, you need the adjoint and the determinant. So I'm going to start with the determinant of A, right? Let's find the determinant of A. We want to get the inverse of this matrix, or we need the determinant and also need the adjoint. All right, so let's start with the determinant of A. Now, the determinant of A, this is A, is going to be this. We no longer use brackets now, use straight lines to enclose the elements of the matrix since we are finding determinants here. So this is going to be 4, 1, 6, 1, 4, 0, right? Now I'm going to assign signs, right, to the first row. This is going to be positive, negative, positive, positive, negative, positive. Now notice how the signs are alternating, because we're going to need this when finding the adjoint of this matrix, right? I'm going to go further. When finding the adjoint, I'm going to assign signs in this manner. This is going to be positive, negative, positive, negative, positive, negative, positive, negative, positive. Just keep that in mind when we get to the adjoint part, right? So let's proceed with the determinant. Now for this first element being 2, it's going to be positive 2, right? And positive 2 is at the intersection of row 1 and column 1, right? So if I just obstruct this row 1 and then column 1, I'm going to be left with 1640, right? 1640. So let's just work with that. You multiply this diagonal, the right diagonal, then you subtract the left diagonal, right? So what's going to be 1 multiplying 0? That's 0, right? Then you subtract 6 multiplying 4, that's 24, right? Alright, so the next element happens to be negative 3, right? Negative 3. So we're going to take down negative 3, and then negative 3 is located at row 1, column 2, right? Row 1, column 2. So if you just neglect row 1 and column 2, you're going to be left with 4, 6, 1, and 0. Can you envision that in your mind? Okay, ignore this and this. You'll be left with a 2 by 2 matrix that's 4, 6, 1, 0, right? So you're going to multiply this, the right diagonal first. That's 4 times 0 now. That's going to be 0. Then you subtract the left diagonal multiplication. That's 6 times 1, right? That's going to be 6. Alright, just try to envision the smaller matrix when you cover the rows and column, right? Now finally we have positive 5, right? And it's located at row 1 column 3, right? Row 1 column 3. Alright, so I'm going to ignore this and focus on this matrix, right? 4 1 1 4. Alright, so the right diagonal multiplication are going to be 4 times 4, right? Giving us 16, minus what's the left diagonal multiplication there? 1 times 1, that's 1. Alright, so this is going to be 2 multiplying negative 24. Alright, and this is going to be negative 3 multiplying negative 6. And this is going to be 5 multiplying 15, right? At the end of the day, you just use your calculator, put in every values, and you should be getting, okay, you should be getting 45, I think. Alright, so the determinant of this matrix is going to be 45. Alright, now we have found the determinant of A, that's 45. How do we get the adjoint? Okay, by finding the cofactor transpose, right? Okay, so how do we get the cofactor before transposing it? Now this is what we are going to do. Alright, let's find the cofactor. How many F's? Cofactor. Alright, let's find the cofactor. Now the cofactor is going to be equal to, I'm going to draw a very big matrix so every element will be clear and visible. Alright, let's get the cofactor. Now the cofactor is going to be a 3 by 3 matrix, right? So we're going to have 1 2 3 4 5 6 7 8 9, about 9 elements. Now how do we get each of these elements? Right? Now the first element here is going to have a sign of positive, have a positive sign, right? The next one is going to have negative sign. Next one is going to have positive, negative, positive, negative, positive, negative, positive. All right, just keep that in mind. I don't necessarily have to write it down, but I want you to visualize what we are actually going to experience, right? Positive, negative, positive, alternating signs. All right, so how do we get the first element here? Now listen, this is the original matrix, right? To get the first element, remember this position here is the intersection of row 1 and column 1. So if I ignore row 1 and column 1, I'll be left with a 4 by 4 matrix 1 6 4 0, right? 1 6 4 0. So let's carry out the multiplication, the diagonal multiplication of that matrix 1 6 4 0, right? 1 6 4 0. All right, this is going to multiply this, right? 1 is going to multiply 0, that's 0, minus 6 is going to multiply 4, right? That's 24. It's looking similar to determinant, right? But of course you've seen the difference. I didn't take into consideration the number there too, right? I just went ahead to cross multiply the smaller matrix we got from the intersection of 2, right? We just carry the multiplication here and we take down the values, assign it a positive sign, right? The next one is going to take a negative sign, the next one positive, negative, positive. You get the point, right? All right, let's get the next element of this matrix, which is actually going to be negative. All right, now this position, the position of the next element is still at row 1 but column 2, right? Row 1 column 2, right? So I'm going to be left with, if you can see, we're going to be left with 4 6 1 0, right? 4 6 1 0. That's the intersection of this row 1 column 1. You're going to be left with 4 6 1 0. So let's carry the multiplication of that. You're going to have 0, right? That's 4 multiplying 0 minus 6 multiplying 1, that's 6. Remember, this next element is going to carry a negative sign, right? The first one was positive. You can see the positive right there. Even if I didn't write it, it's positive, right? The next one is negative, next one is going to be positive. So let's get the next one. Now this position, of course, is the intersection of row 1 column 3, right? Row 1 column 3. So we're going to be left with this matrix right here. So 4 times 4, that's going to be 16, right? Minus 1 and 1, that's 1. All right, so this positive, negative, positive. The next one is going to be negative. Yes, it's longer than determinants. Finding cofactor is actually a longer process than finding determinants, right? Now this position, which is going to be negative, is the intersection of row 2 this time around, row 2 and column 1, right? Row 2 and column 1. All right, so we are done with row 1. We've moved further to row 2, right? So if you cover or just ignore row 2 and column 1, you're going to observe that you have a smaller 2 by 2 matrix that is just made up of 4 elements. That's 3, 5, 4, and 0. Can you visualize that? Row 2 column 1, you're left with 4, 5, okay, 3, 5, 4, 0, right? 3, 5, 4, 0. All right, so we're going to cross multiply as usual. 3 is going to multiply 0, 5 is going to multiply 4. Do you understand? Now 3 multiplying 0 is going to be 0, right? Minus 5 multiplying 4, that's going to be 20, right? All right, there's a negative sign here. Remember our alternating signs, plus, minus, plus, minus. The next one is going to be positive, right? All right, so how do we get the next element of the cofactor? All right, now that's like the midpoint of this matrix, the middle of this matrix, because that's the intersection of row 2 column 2, right? Now take a look at row 2 column 2. We have elements 2, 5, 1, 0 outside this intersection, right? Row 2 column 2. You're going to be left out with 2, 5, 1, 0, right? This is 1. 2, 5, 1, 0, right? 2, 5, 1, 0. So we're going to cross multiply as usual. 2 is going to multiply 0, that's just 0, right? Then 5 is going to multiply 1, that's 5. All right, the next element is going to be negative, right? Negative, and it's located at, okay, this location now is the intersection of row 2 column 3, right? Row 2 column 3. So we're left with 2, 3, 1, 4. Can you see that? Can you visualize that? 2, 3, 1, 4. All right, so 2 is going to multiply 4 and 3 is going to multiply 1 as usual, right? So 2 multiplying 4, that's going to be 8, minus 3 multiplying 1, that's going to be 3. I hope you're following so far. I hope like there is no confusion. But of course, if you have any question, do well or feel free to ask in the comment section. All right, now let's get the remaining 3 elements of this cofactor. All right, how do we get, okay, this is negative, this is positive, this is negative, the next one is going to be positive, right? So I don't need to indicate this sign. I'll just, go ahead with finding the element itself. All right, so this location is intersection of row 3. Now we're done with row 1, 2. We're now at row 3, right? Intersection of row 3 column 1, row 3 column 1. So you can obviously see what's left, this matrix here, right? 3, 5, 1, 6, 3, 5, 1, 6. All right, so this is going to multiply this is going to multiply this, right? So what's 6 times 3? That's going to be 18, right? 18. And we're going to subtract, okay, 5 times 1. 6 times 3 gave us 18. Now 5 and 1 is going to give us 5. And that's it for that element. The next one is going to take a negative sign, right? Positive, negative, positive, negative, positive, negative, positive, negative, positive. Just keep alternating the signs. All right, so where is this guy located at, this element now? The intersection of row 3 column 2, right? Row 3 column 2. Now if we were to ignore row 3 and column 2, we're going to be left with 2, 5, 4, 6. I hope you can see that. Very important. 2, 5, 4, 6. If you're ignoring row 3 and column 2, 2, 5, 4, 6. All right, so 2 is going to be multiplying 6 and 5 is going to multiply 4, right? So 2 multiplying 6, what's that? What does that give us? 12, right? Then 5 multiplying 4, that's 20. All right, then the final element, which is going to be positive, right? This was negative, this is going to be positive. So how do we get the final element? That guy is located at the intersection of row 3 and column 3, right? So we're left with this matrix out here, 2, 3, 4, 1. You cross multiply as usual. 2 is going to multiply 1, 4 is going to multiply 3. All right, so 2 multiplying 1, that's 2, right? That's 2. Then we have 4 multiplying 3, or 3 multiplying 4, that's 12. 1 and 2, 12. All right, so we have found the cofactors. Let's just put them together. All right, let's put everything together. All right, so putting everything together, we're going to have this negative 24, right? 0 minus 24. That's just negative 24. All right. Then we have negative 6. That's 0 minus 6. Then we have negative outside. That's negative 6. That's positive 6. Do you understand? Now we have 16 minus 1. That's just 15. Right. We have negative 20. Right. This 0 minus 20. That's just negative 20. Negative 20. That's positive 20. And this 0 minus 5. Negative 5. Right. This is negative. Okay, first let's look at 8 minus 3. What do we have there? 8 minus 3, that's 5, right? Now there's a negative sign outside waiting for that 5, so we're going to have negative 5 here. All right, what's this? 18 minus 5, that's going to be, okay, that's positive 13, right? Then we have 12 minus 20. 12 minus 20, that's negative, okay, negative 8. Then there's a negative sign outside waiting for the negative 8. So at the end of the day, we're going to have positive 8. Do you understand? Positive 8. This is 2 minus 12, negative 10. All right, so 2 minus 12, that's going to give us negative 10. So this is the cofactor matrix, right? This cofactor. I'm just going to call it cof. Now let's transpose it to get the adjoint. Remember, the adjoint is actually the cofactor transpose, right? Where did I say such? Okay, the adjoint is actually the cofactor transpose. Now let's see how we can transpose a matrix. This cofactor transpose. All right, now listen up. Whenever you're trying to transpose a matrix, you're simply exchanging rows for columns, right? Interchanging the positions of rows for column. Now let's say this is row 1, right? This is row 2, this is row 3. Now this is column 1, column 2, column 3. You understand? Now if I'm to transpose this matrix, I'm going to replace row 1. I'm going to replace row 1, right? This is row 1, right? With column 1. Or you can put it this way. You're going to replace column 1 with row 1, right? Replace column 2 with row 2. Let's just get practical. Now this is row 1 here, right there. This row 1, right? Negative 24, 6, and 15. Negative 24, 6, and 15. Now, if I'm to make this row 1 column 1, this is going to be negative 24, 6, and 15. Do you understand? It was row 1, now it is column 1, right? Now, take a look at row 2 right there. That's 20 minus 5 minus 5, right? That's row 2. Now, I'm going to take that and make it column 2, right? This 20 minus 5 minus 5, that was the second row. Now you can see it's the second column, right? Then we have a third row here. That's 3, 8 minus 10. You're going to, okay, 13, not 3. 13, 8 minus 10. All right, so take a look at what we have. This is row 3, right? Now it is actually column 3. You understand? Okay, let's look at column 1, negative 24, 20, 13. Column 1 is now row 1, negative 24, 20, 13, right? Or you can say row 1 is now column 1. Either way is your right? So this is the cofactor transpose, which is actually the adjoint. We are looking for, right? This cofactor transpose, the same thing as the adjoint. So now we can find the inverse of this matrix. Okay, it's A, right? The matrix A. The inverse of this matrix, remember, is simply the adjoint divided by the determinant of A, rather. The determinant of A, right? Now we have the adjoint in our graphs, right? Where's the determinant? Okay, we've got the determinant as 45. So let's just divide these two and we'll get our inverse. All right, so the inverse of this matrix is going to be, this is negative 24 over 45. I'm going to be dividing each element in this matrix with the determinant. All right, I'm going to divide each element there with the determinant. All right, so this is 20 divided by 45. This is 13 divided by 45. This is 6 divided by 45 minus 5 divided by 45. 8 divided by 45. 15, that's this, right? Divided by 45 minus 5 divided by 45 minus 10 divided by 45. It's a bit disorganized, but you get the point, right? Now this is the inverse of the matrix. Of course, you should feel free to simplify where possible, right? Let's simplify the fractions where possible. All right, this is going to be -8, right? -8 on 15. This is going to be, okay, 4. 5 going to this place is going to be 4. 5 going to here should be, okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that should be 9. Now there's no common factor here, so this is going to remain 13 and 45. Going to be 2. Okay, it's the same thing as this. Okay, this one is similar, but similar. Alright, so 1/3. 15 can go here once, 15 can go here 3 times actually. Okay, 9. Alright, so finally this is the inverse of this matrix. Alright, the inverse of this matrix. Now you might be wondering, oh no, what if I've made a mistake along the way? What if I've made some errors, had some errors? How do I verify my answer is correct? How do I verify my answer is correct? Now I don't want this video to be very long, right? There's a way you can verify. You can check if your answer is right or wrong. Okay, this is what you do. That's where identity matrix comes in. Now if you multiply a matrix with its inverse, you should be getting an identity matrix, right? If you multiply a matrix with the inverse, you should be getting an identity matrix. What's an identity matrix? Now, an identity matrix is a right? Is a right diagonal matrix with just 1 as its non-zero digit. Now, look at this. And it's always a squared matrix, right? It's a squared matrix, 2 by 2, 3 by 3, 4 by 4, and so on. Now look at the basic form. That's 2 by 2 squared identity matrix. You can see it's a right diagonal matrix, right? 1 0 0 0 1 0 0 0 1. All right, this is still an identity matrix, 3 by 3. 1 0 0 0 0 1 1 1 0 0 0 0 0 0 0. All right, so this is still an identity matrix, 4 by 4. All right, so we're saying that if you multiply A with its inverse, you should be getting an identity matrix, right? So you're going to try this out. All right, you're going to try this out. This is A, 2 3 5 4 1 6 1 4 0. This is A, right? Now we have the inverse of A to be -8 over 15, 4 over 9, 13 over 45, 2 over 15, -1 over 9, 8 over 45, 1 over 3, -1 over 9, -2 over 9. This is the inverse of A, right? So now you're going to try multiplying this with this. This is a chance for you to practice matrix multiplication of matrix, right? Remember, you go in this direction. All right, you go in this direction. You use this term to multiply this, use this to multiply this, use this to. Okay, let me just give you a hint of what you should be doing. Very big matrix. All right, so this is going to multiply this, right? This is going to multiply this. 2 times 8, that's -16. Plus, this is going to multiply this. 3 times 2, that's 6 over 15, right? Then finally, this is going to multiply this. That's plus 5 over 3. That's how you get the first element of the matrix. You're going to get the next, next. All right, how we got the first? You observe, we use this to multiply this, use this to multiply this to multiply. We move in this direction, right? Now, how do I get the next element? We're going to use this to multiply these ones. As 2 is going to multiply 4 over 9, 3 is going to multiply this, 5 is going to multiply this, and that's how you get next elements. Remember, you're adding each of those multiplications, you're adding them up, right? Then how do you get the next one? This is going to multiply this again, this is going to multiply this, this is going to multiply this. Of course, you're adding them up. How do you get this? You're going to get a squared matrix 3 by 3, right? And if we sum this up, okay, let's check this out. Remember, we said we should be getting an identity matrix. So this should be 1. The sum of every term here should just be 1, right? The sum of every term is 0, 0, right? 0, 1, 0. You understand? So I'm just going to check. We're just going to check. Okay, check this out. Is this going to sum up to 1? Yes, it's going to sum up to 1. Let's try the second one and see if it's going to sum up to 1 as well. Oh, sorry, 0. This is 1. This should be 0. This should be 0. Right? 1, 0, 0. 1. You understand? You get the point. Alright, so let's do this. This is going to be 2 multiplying 4 over 9. That's 8 over 9, right? 3 multiplying negative, that's negative 3 over 9, right? And finally 5 multiplying negative 5 over 9. Alright, so the LCM of this is going to be 9. Okay, just going to be 9. Now this is 8 minus 5, 6, 7, 8. 8 minus 8, that's 0. 0 divided by 9, that's going to be 0. So you can see this is 0, right? This resulted in 0. And this is resulting in 1. The sum of all this here is giving us 1. It's giving us 0. So you can go ahead to try the others and, just practice, right? After all, they say practice makes perfect. Alright, so I'll see you guys in the next video. Subscribe, of course. Have a good day.